Okay, my name is Will, and we did a lesson today on Earth and space, and this is my blog post on lesson 10, Our Sun is a Star. What factors contribute to a star's brightness? The distance. The distance is a factor because for example, once like a flashlight is close to your eyes and pointing at you, it's brighter than it is far and pointing at you, like in this photo. Like pretend this was a flashlight and this was a flashlight. It would be brighter because it was closer and not as bright because it was farther. But if this one was so much brighter and so much bigger, it could look almost the same size and close to the same brightness, but like that, I don't think that would happen. And the temperature, a star's the temperature is part of its. The brightness is caused by the temperature. It's usually brighter when it's hotter, and the hottest is blue over to red, and it goes from red to yellow to white to a light blue to a bluish and a dark blue. And dark blue is the hottest and red is the coldest. Like if you look in the sky and you see a red star, then it's not as hot as one of the blue stars you see. And the temperature, well, not as hot, but like the temperature is less. Then the temperature is less when it's red than it is blue, because when it's blue it's hotter, and like everything in between. And like the brightness is measured by the temperature, so a blue would be brighter than a red. Usually, like a blue would be brighter than a yellow. Like for example. And what factors contribute to a star's brightness, distance, temperature? Oh, the size contributes to the. The size contributes to the star's brightness because the larger of two stars with the same temperature, at the same distance is right. Like so, the size, the brightness is determined by its size. So if it's bigger, it's probably going to be brighter. But like if it's a red that's bigger, it actually will be a lot brighter. Like I said before, like blue would be super bright and red wouldn't be. Red could be if it's a really big one, it's going to be it could be brighter than one of the smaller planets. It's one of the smaller ones that have a higher temperature. And yeah. LeBron and Trina are talking about our sun and other stars. Trina argues that the sun is much larger than all the other stars in the sky. She also explains that most of the other stars are about the same size as each other and the same distance from Earth. LeBron disagrees. He explains that the sun looks larger than the other stars because it's closer. He also argues that the other stars vary a great deal in size and distance from Earth. LeBron is correct because the sun, it appears to be the biggest. It's not the biggest. The sun, let me see, it's actually right on the point of my cursor, right there. It is not even close to one of the biggest or brightest stars. It's just LeBron's also right, and she's also wrong because LeBron explains that it seems like it's bigger because it's closer and brighter and brighter because it's closer. But he says like all the stars look this, and Trina says all the stars are relatively the same size. That's not true. It's just most of the bigger stars are farther and the smaller are closer. I don't know if that's true, but like It's not determined. They're not all the same. They're all different sizes. It's just factored by the brightness, distance, and the brightness, the size, the temperature, and the distance.